welcome to today's webinar, New Features in RISA. I'd like to introduce, we released the new features here about a couple months ago, and what this webinar will do, will focus on talking about some of the bigger features and some of the things we can demonstrate how to use them in the different programs. One thing I will add is we're going to also introduce RISA Connection as a nice way, because we did release that as well. So we'll have 4 programs. So hopefully we'll get a lot covered today, and feel free to ask questions to Amber along the way if you have as we go. So starting out, you'll see here we'll kind of start in RISA 3D and RISAFloor. And let's see if I can. One of the things that we RISA 3D, RISAFloor, and RISAFoundation is we added a brand new 32-bit and 64-bit versions. So what happens there is that automatically your computer is going to detect what type of system you're operating, 32 or 64-bit, and it will automatically install for you. So there's nothing you have to do. On your side, you're all set. It's all automatic. But what it does is it opens it up to the folks who have 64-bit machines gain a little bit more information here. So if we look at kind of the comparison of the limits of the program, for a 32-bit machine, your joints are at 100,000, but with 64-bit, we're getting up to 500,000. Same thing, members and plates. All of the limitations that stop you on how many members you can create or how many plates you can create all get bumped up significantly higher when you go to 64-bit. So we're taking advantage of a lot of those different pieces of information and being able to take that to a higher level for 64-bit. Again, don't worry, there's no requirements for you to do anything on your side. The installation is all automatic, so you'll happen behind the scenes. You won't even know it, but you will take advantage of that if you have a larger operating system like that. So that's a great thing that happened in RISA 3D, RISAFloor, and RISAFoundation. Going also forward, this is a very large code release. So we are fully IBC 2012 compatible, and we'll see a lot of different material codes were updated in RISA 3D and RISAFloor. So one of the big things here is that we got wood design for the NDS 2012, so that is up to date. We also added aluminum design. For the ADM, it's actually 2010, and now that one was a significant change. If you're used to any of the aluminum design in 05, that was kind of built off of the older codes. Aluminum and hot rolled are similar in their codes, and the 2010 aluminum code really mostly follows very closely to the 13th edition or the 14th edition of steel. So it went to a little bit different, but it actually combines ASD and LRFD nicely, and it's actually very easy to follow there. So aluminum design, if you're in the 2010, you might see very things like P delta is being required, and it's using adjust stiffness methods, things like that you might be familiar in hot rolled. So that was added. Cold form steel was added for the 2010, and that was kind of a minor update there, but up to date with 2010. We also added the seismic design for 2010. That's the ISC 341 2010. So you've got that up to date. A big one that people have been asking for years, and we got the design guide from the folks over at AISC, and so we implemented that tapered wide flange design. This opens up a lot of doors for tapered design, and it's really nice to have that in there. And when we were taking a look at that, we had some time to work on enhancing that feature, and so I want to show you guys how that would work inside of RISA 3D. So I'm going to show you an example of this. So let's open up a model I created. So we'll pop into RISA 3D. Oops, let's see here. Sorry, I'll go right into RISA 3D. And what we've got here in RISA 3D is I just built a sample frame, and you can see it's tapered. And all you really have to do is go into the codes parameters here, and we're in the hot rolled steel, and that's really what's delivering that. So there's nothing, we have 13th and 14th editions, and both of those will help us pick out that tapered design. So if you're using either of 13th or 14th, we're going to be using the newer tapered design for Design Guide 25. So when I solve this model, if I just created a simple load combination. Let's just quickly see. All it has is some line loads on there, and I'm going to solve that, and we'll just create some solution here. And what I really want to show you is some of the enhancements here. If I click on the detail report, This is our typical RISA 3D detail report, but what's nice about it is at the bottom we really expanded this detail report to show a lot more information. So if you're familiar with our detail report, you can see some of the information that's similar in 14th edition. We talk about compactness, and we also show you some of the capacities, but you also see some governing equations pop in here. So this really helps us actually see more information based on what's happening in this code check. Now we have the equation listed here, and then we have some kind of parentheses showing a little bit more information. And what I'm going to do is open up the help file to help us see this a little bit closer. If we open up our results here, we can see our hot rolled design results, and I'm just going to scroll to the bottom, and it'll tell us exactly, for the tapered design, a little bit more information about what we're looking at. So if we see here that we actually have some codes, so CAT is in parentheses for this equation, and that's governing for our axial. So what does that mean to us? And in here, the help tells us that is constrained axis torsional buckling of the member due to axial force. So it gives us a little bit more of a clue about why that might be, that code check was selected there, and it gives us the elastic and the plastic limits as well as the slender ratio. If you're familiar with aluminum, this is a very similar kind of format. The other one we see here in parentheses is LTB, and we can see that from our help file. We can see that that's lateral torsional buckling of the member due to flexure. So this, in the help, it really helps you kind of see a little bit more about what we're looking at in this design results. For more information on that, if we click on the design here, it'll tell us a little bit more about every one of the design checks that were done. So in-plane flexural buckling, and we see more about torsional buckling here. And we scroll down, we can see the constrained axis that we mentioned in our detail report, and then some of the other strength checks that we see. So it's a really great, if you look at the help, if you're going to kind of work with tapered, to see what is being used and what's being checked. And I really like the way we enhanced this detail report to help you a little bit more information. So let me pop back into the presentation, and let's see here. The other ones that we added were Canadian code checks and code updates. A lot of the Canadian folks got a lot of their updates here, and starting with the hot rolled steel, we've given you the 2009 update there. Cold form steel, this is really very similar to what we're working with in the States here. So it's just the LSD versus LRFD, and so we've got that in place. As well as we had the seismic and wind load generation for the NBC 2010. Also pretty similar, but there were some changes along the way that made a difference in there. But you'll see that when we do some automatic load generation. And actually another model we'll see that. We also added the response spectra for NBC 2010. So if you're doing the dynamic analysis, you'll be using that new response spectra in Canada. We also did the load combination generator, so we updated it so that it is using NBC 2010 too. So that's kind of our bigger code ones, and we kind of had a lot of different codes in this one, and sometimes codes can be big releases like this, and then sometimes codes now will probably have a little break from codes and lots more of other types of features. But we did have a lot of modeling features as well, and the DXF import is a big one. Now I would like to just this is a feature we've added as a grid line import. We've always had DXF import and DXF export, so you could just import a model in and then you could just export it out. Now what this is going to do is actually act more like a drawing grid. It was going to lay it kind of behind the scenes, and you can click to that drawing grid using this DXF background image. So this is it will be just where we see where the drawing grid options are. It's just an extra tab there, Import DXF, and it allows us to walk through and enter in the different information, the drawing plane, and it tells us the factors and scaling factors. And then we can select a DXF. I'm going to show you guys this in action for both RISAFloor and RISAFoundation. But I want to make sure we see this is a great feature in order to help you draw your model in RISA versus the DXF import where you can actually import a full drawing and actually just be the model. So this is a little different than that. The other thing I want to talk about is the added virtual joist girders. So this is a new feature here into this RISAFloor and RISA3D, and what we have is a database here that is actually called virtual joist girder. So instead of AISC database, you're actually seeing this as you drop down and select the virtual joist girders, and we can pick from that different list of the different types of girders we have. The SJI came out with a list of parameters that we can use, and we can just plug that right into the program. So this goes into both RISA3D and RISAFloor, which is really nice. And what it does is it's going to convert the common joist sizes into equivalent wide flange beams. So you're going to actually see them in the WF. That's a really important thing. You're not going to see like a girder listing here. It's really just an equivalent of the wide flange, so the WF selection on the shapes type here. A tip there for using this, though, would be to make sure that you set your design rules so that the depth is correctly picked. So lots of times, really, when working with joist girders, it's really important about the clearance underneath there. So in order for us to help you select that properly, you really want to set up a design rule with a maximum depth. This is 48 inches, pretty deep, but that would be helping you to select the joist girder that might be most optimal. So that would be something you probably want to use if you're going to be using these joist girders, or at least letting us design them for you. So let's see here, I'm going to show you these features a little bit more in depth. So I'm going to open these up, and let me just make sure I close my RISA3D model. I'm going to shut that down, and we'll open up a model I already started in RISAFloor. Now in RISAFloor here, we're going to talk about a couple different things, the two features I just mentioned, so DXF import, as well as we'll talk about those joist girders there. And hang on, just as we open, we have our nice splash screen here telling us we're in version 7. And we'll see here. So RISAFloor, let's see, is going to open up. And we'll launch in just a second here. Okay. We open up to our global parameters, and I'm just going to say OK. And I'm going to kind of show this model a little bit just to take a tour so we understand what kind of model we're looking at. It's just a 3-story model. Okay. As we look at this model here, I'm going to go to my down the structure here and just see my second floor. Not much to the model, just a nice kind of basic floor plan, second floor, third floor, and as we go up to the rooftop here, we see just kind of a little small roof, maybe penthouse up there. So if I go back to my second floor, what I want to do is maybe add an awning of some sort out here. And what I'm going to do is use my DXF import tool that is brand new in order to draw that awning. Now, the way I do that is I'm going to go straight to my drawing tools, and I'm going to go to my drawing grid. Okay, and so I'm clicking on modifying the drawing grid. Instead of doing the drawing grid there, I can use import DXF. Now, like we saw earlier, this dialog, it just tells us where we want to place this. And we're just going to throw this in the 0, 0 location, and the scale factor we might want to use and what plane. Now, we'll just use it in the plane we have, the XY. And I'm going to choose this file, and I just browse to it. It pops open a list here, and I think that list is actually going somewhere behind the scenes. So here we go. There we go. And I'm just going to navigate to that location. So on my desktop here, I'm going to go to New Features, and I'm going to pick the one I created, which was called Arc Import. So if I import this, it gives me a new dialog box, and what it's telling me is use all layers, or I can select the layers I'd like to import. For mine, I'm just going to say all of them should come in, and I can say done. And as I see behind the scenes, this arc that I created here to help me do this awning was imported. Now that's not an element, it's just a drawing grid. So if you're familiar with our drawing grids, you remember that it's sort of gray in the background, and this is just like that. What it allows me to do is click along its length or at any intersection. I told the program here how many, I can click along that radius every 5 degrees when I clicked on that to import it. So what I'm going to do now is I'm going to just sort of draw in some columns along there. So I'll just put in maybe some A992, wide flange, gravity columns, and I'm just going to drop one maybe there. We'll see I'm just clicking on the intersections, and maybe I'll do one in the intermediate points here, maybe like in the midpoint there, and maybe another midpoint, and somewhere else in here. Okay, so I'm just going to draw these columns in, and then I can draw some beams, and I'm going to say that they're going to be A992 gravity beams, and I'll just sort of draw a couple beams just to frame out this area. So what it's allowing me to do is really a nice clicking point for drawing this members in. And this is sort of, a different approach for if you wanted to import. This helps you draw. A little bit different than importing the whole model. Okay, so once I've got that in place, let's do one more beam here. I'm going to just put a slab edge around this at the exterior, so say apply, and I just draw in my slab edge. Now, let's see, one more beam. I think I have one more beam missing here. Okay, so if I go ahead and draw in here, I am ready to then run the model. One quick thing before we run our model, I wanted to just take a quick look at the top here, at my roof level. At my roof level here, what we see is that if I just show you my shape labels, let's see, I'm going to go and show you my shapes. What I have in here is K-joists, but I use the girders, the virtual joist girders, kind of around the structure. I also just use them here maybe for some of my framing that's going to be the lateral system. So I'm going to now run this design with these virtual joist girders as well. So I'm going to solve this. And as I'm solving here, just a quick preview here of if you're not familiar with RISAFloor, what we're doing here is we're looking at the model just like we would in RISA 3D, but we call it RISAFloor because it's floor by floor. So what we're doing is we're flipping between the floors. It helps us really draw a building much easier and much quicker. And when we see these listed K-joists and we see virtual joist girders, that's actually designing them. So we didn't tell the program specifically what to use. The program is using the design parameters we set up ahead of time, and it's actually designing them based on what loads we have for area loads. And we can see up here on the top, as the solution goes by, it's optimizing those beams for us based on our criteria. So it counts the loads down the building, and then we get a design at the end of the solution. Now, what's happening, why we see things in red versus in blue, the red ones are only the actual lateral members. So the blue members are gravity members. So here in RISAFloor, we design all of the gravity members down the structure, including those red elements. And then when we go to RISA 3D, only the red elements will go over to RISA 3D. So only part of our lateral system will make its way over to RISA 3D. So we get to take advantage of a lot of different things here in RISAFloor, like composite steel design. We get things like live load reduction. We get vibration analysis, all sorts of stuff. And one of the nice things, too, is actually steel joist design here. We're seeing that as well. So we've got a lot of different pieces of information here in RISAFloor that get carried in here and get designed only in RISAFloor. What we're seeing here, we've got our joist design behind the scenes. Everything got designed, and also our joist girders, which is very nice. A joist girder is really, like we said, just kind of an equivalent wide flange. So if I click on the detail report and then click on that actual member, I just see really the same type of information I would have normally seen if had this just been a wide flange. It tells us all of the design information, the loading. As I scroll down, I get the code check, and it's based off the shear and the bending and deflections. Okay, so very similar to what you would have been looking at a wide flange. Now, joists are just a little bit different just in comparison when we're looking at the joists. Let me pull up a joist detail report. What we do there is we do a little bit more of equivalent loading here. So you can see it takes a load and distributes it into the dead and the live. And as we scroll down, we see that we do an UDL, which is going to be uniform dead load or uniform live load, and breaks it into fitting it into the joist tables. So just slightly different for joist design versus the girders. Okay, if we scroll down the structure, we just see that we put in that little awning area, and that got designed around the structure here. That was just gravity design, so it's going to just keep it right here in RISAFloor, not go over to RISA 3D. And we can just sort of see that we have all the rest of the structure is being designed here in RISAFloor. So I'm going to go to the Director button and go over to RISA 3D. And we can see that here in RISA 3D, as we make our way over, we have the automatic load creation here for our wind loads. We see the ASE 710 there listed with the newer ones, and we can also see here that NBC I mentioned. And so we'll use that ASE 710. You can see that we have a calculation of all of the winds. It gets applied each floor, and there's the calculations of that wind, and we see forces in the X and forces in the Z directions. Applied at each floor. I'm going to say OK. the seismic as well here. So we could have selected here that any of the Canadians that we have brand new, NBC 2010. We'll stick with the ASE 710, but what you do have here is a seismic calculation. And as I scroll down a little bit, I see similar to the wind, this is broken up per floor. We see the total base shear calculated at the bottom there, and then applied at each floor there. So I'm going to say OK, and I'm going to pop out here. And what I see is, which is really nice and brand new there, is that we actually can carry those virtual joist girders at the top over to RISA 3D, which is a new thing because previously they would have been working off of tables, would have not been able to carry over to RISA 3D. But since in here we can actually count on them part of our lateral system. Now, I don't know how often people do that, but we have had several requests for that, so it's a nice thing that you can actually take that virtual joist girder right over into RISA 3D for lateral design. So I'm going to run this model here, and we're going to end up going over to RISAFoundation. So I'll just run a batch solution for us, but I want to be able to, let's just jump back and talk a little bit about what's happening in RISAFoundation, some new stuff. So we added a lot of brand new modeling features in RISAFoundation. If I take a look at one of them in particular, it's called an offset slab. Now this is the most useful tool for when you're using RISAFoundation from within RISA 3D. In RISA 3D, we automatically bring your point loads in from your joint reactions. So I'm looking at here, I can see that there's little point reactions coming in from RISA 3D in the RISAFoundation model. And sometimes you just want to sort of drop a slab all the way around the whole area. But it's hard to do that because you will have to click to a joint. So this offset slab tool makes that really easy because we can just draw a slab around the perimeter of all the joints we wanted to cover, and then using an offset, we can just tell the program to pop that slab offset by a certain distance. So we say go from actually being directly on the joint off by maybe 5 feet, and that will just offset it, and then it's now a larger slab size. So I'll use this tool here in the coming models, this model we're working on, and kind of demonstrate how easy that is and how nice that feature becomes when you're in RISA 3D to RISAFoundation. So the other features we added, we allowed you to add openings and also thicken a slab in certain areas. This is really great tool. Helps you modify your slabs in a really quick way, and I'll demonstrate that as well. I'm really happy about this one, and you can kind of see the thickness of that slab is different on the inside versus on the outside there, and we'll see that as well live. The other features here we've added is copy. So copy has been around for a long time in RISA 3D and it's been in RISAFloor. Now it's in RISAFoundation. So this is really helpful if you have different items that are selected here that you need to copy from one side of your structure over to another. Beams, retaining walls, footings, pedestal slabs, all of that can just be copied over. You can do copying elements by linearly. You can do point click to click, a point, by an angle. So there's a lot of different options for copy. If you're familiar with some of the newer versions of RISA 3D and RISAFloor, we added some brand new copy functionality in there as well. So it's kind of a nice tool. It's just carried right into RISAFoundation. We also added the ability to add line moments and line horizontal forces. So you can see, you can sort of have some more control of that inside of RISAFoundation. So let's all see how we kind of work with this model, with the one we've been working on. So I'm going to just jump back into it, and it's going to tell me, a little warning I didn't do P delta, but that's okay. So once I've run this model here, what I see is I'm going to have joint reactions. We can just sort of display them for fun just to see how they are on the screen. If we look at our joints reactions, we can see maybe some of that happening here. So all of these loads are going to be carried down the structure for the wall and for all of the frames, and we see that we have reactions. We also see joint reactions in our spreadsheet. So if you're familiar in RISA 3D, you know all of this area here. You can see exactly in the joint reaction spreadsheet, or you can see it graphically. All the members are being designed here in RISA 3D as well. Okay, we have design results, and we could have gone through some of these design results. But what we want to do right now is I want to demonstrate how to go over to RISAFoundation and see some of the different features we have there. So I'm going to take the director button at the top right corner and go over to RISAFoundation. And it carries all of those loads for us. You can see it quickly builds all of those. They come across based on the load category. So at the top of the screen, we can see we have dead loads, we have live loads, we have different types of loading. I think we had some wind loads here, obviously. We used wind loads in the X direction. Okay, so we're seeing all that different loading in there, wind loads in the Z direction. And that all gets carried right over from RISA 3D into our model here in RISAFoundation. So let's go ahead and just kind of get back to our dead loads just to see. And what I'm going to do is turn off that loading just so it's easier to show you some of the clicking and some of the modeling tools. So now we're just looking at the base nodes that are coming from the model. What I'm going to do is just use that offset slab tool. So I'm going to go ahead and start drawing a slab right around the edge of my structure. I'm going to go and change the slab to maybe a 24-inch slab. And I'm going to click on here, this point up here, and I am just going to go around and sort of outline my whole structure. So I will go ahead and click on every joint on the exterior and create this slab. And let's see here, click on this point, and I'm going to scroll right around there. Okay, so we've got sort of a nice sort of outline of our building, and that would be kind of an odd thing to do, though. You wouldn't really want a column coming right down on a corner of a slab. You do need to offset that. So that's what this tool is that I'm talking about. It will offset the slab. If we click on here, this tool here, we see some new tools up here. This is our slab edge by offset distance, modify it. And I can click on that, and it tells me here I can offset this by a certain distance, let's say 4 feet. By the way, this works in negative and positive directions. So I'm going to be offsetting it positive where it goes bigger, but I could also do a negative and it would minimize. I'm going to say apply, and then I'm going to click on that, and I see that it pops the whole slab out larger. It creates new nodes, and the slab now is 4 feet from where it originally was. That might be a little bit more common here than having a point load right on a corner or an edge. So with that in place, I can also do some more modifications to my slab using my other tools. I have the slab tools that affect the openings and the thicknesses. I'd like to create an opening, but I don't really know where to click since I really only have these large grids. But what I'm going to use is my DXF import. So I actually went ahead and modified a drawing of this slab to help me guide me where my openings might be. So just like you saw in RISAFloor, I'm going to open up this drawing grid tool and go to import the DXF, and I'm going to browse for the file. So I'm going to find this file here. It's right on my desktop. I'm going to go back to my desktop, new features, and I'm going to find this foundation plot that I created. Say open, and I'm going to say done, apply, bring in all of the layers that I want, say done. And I can see I kind of have this little gray line of where I want to make some modifications. So I'm going to have maybe some sort of an elevator bay where I have a big hole in my slab, and I'm going to go ahead and drop in an opening. So I'm going to click on Create Slab Openings. And in the openings, I have several options. So I can either do polygons, or I can do a rectangular shape. The rectangular shape can be drawn by clicking 2 points, or by just clicking on a center point and dropping in an opening. I'll use the polygon here. I'm just going to say apply, and I can just click on that background DXF to create this different area here. Click on it, last click closes it, and it turns this blue, this kind of a aqua color for me to show you it's an opening. I'm also going to drop an opening over here. Just going to put a couple openings in my structure. So in my slab there. So when I have those openings in place, I'm going to just double check and show you here so I can show you where it's rendered a little bit more. You can see that that is an actual opening in the slab. The other thing I can do is modify the thickness. So for some reason I decide I really want to make this thickness right here maybe extra thick. Maybe there's going to be some equipment on there and I need to spread it out with these columns here. So what I'm going to do is I'm going to go ahead and click on the same tool, the Modify Thickness or Opening tool, and I'm going to go to modify the slab thickness this time. I'm going to tell the program I want a 28-inch slab in that area, and I can use the polygon tool just like that, or either way I could have done the rectangular. In this case, the polygon really makes sense since we're going to kind of work around a polygon shape. So I'm going to click on the different outlines of this DXF grid I imported and click around here, and I will finish that off with a last click, and I see it changes color. Now, that helps me indicate that it's thicker. What I also can do is sort of just double click on it. The rendering, see a little bit thicker there, and I can see exactly what else is showing there. You can also use plot options to display the thickness so you know what thickness you used there. So I've got a bunch of different tools now to help me modify this slab, which is really great. The last one, I really don't have much to show you because I don't have anything to copy, but I do want to just indicate that it's here is this copy tool. And as I mentioned, you can copy point to point. You can tell the program a linear increment. You can use a diagonal. If you click on that checkbox there, it'll skew the copy, or you can use an angle and offset it that way. So there's kind of a lot of brand new tools that are just so helpful for drawing your foundation here in RISAFoundation. So let's just jump back and talk a little bit more about some other things here. So RISA Connection was released as well, and so there's a lot of added features into RISA Connection. RISA Connection has added a code, which is a big one. We said it's the AISE 360 14th edition. A lot of times we mention it as a 14th edition steel code. That was added. We added a lot of direct weld connections. So you can see here we have basically direct weld for beams. We have them for moment splices here, and you can see the options under the moment. You've got 3 different types here for column splices, column to beam, or beam splices. We also enhanced the bolted end plate moment connection. So we added that 8 bolts option. So previously you weren't seeing the 8 bolts now. Now you can see 8 bolts there. We also added the thin plate prying considerations there for the design guide 16. These are kind of some bigger ones in the connections. You also added the ability to do a full depth shear tab connection, and you can see that. It's kind of a nice way to just do that full depth there where you can connect it to the top and the bottom flange. We added the ability to consider moment due to eccentricity and a clip angle shear connection. That's a brand new feature there. The other ones we have is, and a lot of folks were asking for this one since RISA Connection here. We've had folks ask for this one. We added the design of the column transverse stiffeners and web doubler plates for moment connection. And you can see both those options here in this picture. And this was something, I personally got a lot of requests for. So hopefully that gets a lot of people excited about using those. And then let's see here, our other options too is we added an improvement to the report printing generator. So previously you just printed the report and it came out a full report, but now you can really go ahead and it's a lot more like RISA 3D where you can really tell the program what you want for that reporting, what connections you want to be importing, and then exactly you can add or remove certain connections. So maybe you don't want to show all of them. Maybe you just want to show a couple. I have 3 connections in here, and I'm printing them all. But you can also describe whether you want to do the global parameters or if you want to do the 2-dimensional views and the 3-dimensional views, or the limit states and exactly what types of things in the members reports you want to do. There's a print preview, and that's something that folks have been asking for too. So you've got a lot of different options here in printing that might be really helpful for you to get your calculation reports done. So we can see here the buttons that you're going to be pushing are going to be the print button, and then the CV button there is going to be a print button. That CV indicates current view. So you would actually, this print button will bring you to this screen. The current view will just print whatever you're looking at that point. So you don't have to step through this entire reporting if you don't need to. So you've also got some updates to the vertical brace connections. We added the ability to specify any size gusset plate regardless of the length to width ratio. And you can adjust that there in your component. You can see you can do a 0 moment uniform force method, or you can just tell the program unlimited, so there's no limitation on the ratio, length to width ratio. You can just say unlimited. And you'll see that in your top brace components listed there. And I can show you that too. The other thing is you are allowed now to use a non-concentric brace work points, okay? And let's see how this works. Let me open up RISA Connection. We're going to just pop up let's see here. Okay, RISA Connection opens up for us right here. In RISA Connection, let's see, we're going to open up this one that I'm talking about. So we have a direct weld connection here, but the one I want to look in particular is our vertical brace. And we can see this is RISA connection is just giving us a vertical brace connection. I'm going to pop into the 2D view, and I can see here that it just shows me a breakdown of what's happening in this two-dimensional view. And we see that we've got a brace coming right into that location. If we look at our general tab here, this connection, if you're not familiar with RISA connection, what we have here is a two-dimensional view, a three-dimensional view, and on the right side of my screen I have connection properties. And there's some tabs here. So it tells us the general tab breaks up the different pieces of this general connection here, loading, the categories, what type of connection it is. We can connect above and below the opening, above and below the brace. We can do a beam connection, talk about the beam itself there, or we can talk about the top brace portion. So in the general section, if I look at that, I can tell the program here to be a concentric connection, or I can also tell the program to be a non-concentric connection and to go along the beam, for example. So if I tell the program to go along the beam, we see that it actually shifts the work point. And I can adjust that shift by either clicking on the drawing, or if you notice when I click on that drawing, it highlights the element here that tells us this is the distance from the column center line. So I can click on that, and I can just change that to be maybe 12 inches, for example, and it will shift that, that actual brace off that work plane. What else I can do is I can just sort of flip it back to be concentric. Let's just say it's back to being concentric, shifts it for us. What I can do then is maybe go from there to along the column, if that's a better location for you. And so I can go there. And if I click on that there's a number right here, 9. I know where that is, but sometimes it can get confusing which ones you're going to click on. So that's okay. You can also just tell the program on the right side, 9 instead of 9 inches, maybe you're going to do 12 inches. And again, it will shift it up and down. Now, once I did that, okay, this plate doesn't really work anymore. Okay, we're coming off that plate. And what I could do there is I can change the actual size to be whatever I need it to be. Okay, right now the width to length ratio is set to unlimited. So I can tell the program really whatever size I want to be put here, so maybe 20 inches. And if I increase that, not quite enough, let's say 24. I can start to see as it kind of grows the plate, and then I'm allowed to do that now so that it will be a little bit of movement created there. So this gives you a lot more freedom in your vertical braces to sort of get to the geometry that you might need. Now, if you're also just to kind of recap, and if you're not familiar with RISA connection, we have a reports. Finally, at the end of the day, you get to set all of your parameters, and then really what's important to us is what does it do for code check. So we look at our reports, and we can see here, we see a breakdown. Now this is a summary report, so it's telling us that right now it's not, we need to verify the bolt, no prying assumptions there. So what does that mean a little bit more? We can take a look, but everything else seems to be passing. So top gusset beam connections are passing. It's giving us the reporting, the controlling limit state, and the maximum unity check that you might be getting. To review what's happening in this failing one, we can go over to the beam column and see, oh, okay, that's what's happening in there. We're failing, and it tells us some big red letters, failing, and we can kind of scroll down the list and figure out why we're failing, what we need to do there, okay, to size that up. What I love about RISA connection is that it gives me a nice code check listing here. It tells me exactly what page there I'm supposed to be looking at, so I know if I'm not really familiar with what happened here and why, I have all the parameters, and then I have a code reference, so I can just go straight to the code and figure it out. But even for some other things that maybe you are quicker a little bit, but you want to just say, you can quickly see what code reference there and why that is maybe the higher one that we have, 0.89, once we solve some of our other issues. So you've got that all listed out, and this is kind of your report for just your beam to column connection. You can also go through all of your different types of connections and break them up, and I'm just clicking on them to expand to find out more information about this. So that's our RISA connection, some of the vertical brace improvements. We did talk that they have direct weld options as well, so you can see that you have this listed here as well. Let's go back to our presentation and I'll talk a little bit more about RISA Connection. So integrating with techless structures is coming very soon. So that would be the next thing to look forward to. And in the next full version of RISA Connection, we're going to be seeing HSS connections. Again, that's something that folks have been asking for a long time, so I'm real happy to say that that will be in our next version coming up. The other piece I want to talk about a little bit about is our verification problems. We did spend a lot of time adding some new verification problems to the programs. You'll see that in RISA 3D we have new examples for the 14th edition. We also added aluminum design examples. In RISAFloor we have a lot of new stuff in there: composite beam design, vibration analysis, steel joist design, live load reduction. So you'll see some new stuff in there for those verification problems. This is a great way to get familiar with how the program is doing things too, to take a look at these verification problems. RISAFoundation, you have footings, retaining walls, and pile caps, some brand new hand calcs or textbook references, and then RISA Connection, we did some 14th edition verification problems. So if you're looking to find these, you can find them on our website, or you can just find them in your own CRISA directory. So if you have the newer versions installed on your computer, there's a CRISA directory, and you'll find those right in there. Let's see, I want to make sure we hit the website quickly. I'm going to just jump over to see if we can pop into the web, and we'll see. Let's go into our web page here. So what we've got is, we look at RISA. New features here are something that we post on our website. And if you're not familiar where to find that, you'll see that there's a brand new tag here. It says RISA 3D version 11 now available. If you click on that banner, what you get is to our new features page. We also sent you an email. Most folks should have received an email saying that there's a new features website. But if you haven't, that's an easy way to get to it. And it breaks down all the new features here. So for each program, it tells you a lot more information. And what's really cool too is that we actually do videos and tutorials as well on some of these new features. So if you're, go through this webinar today and you say, I wonder what Debbie was talking about with that, and I'd love to see more, there's tutorials on almost every one of our topics. And then there's also videos, and those are YouTube videos that you can see. Now the tutorials too are really good to see as well. If we click on one of those tutorials, what we're going into here is our website called RISA News. And RISA News will pop up in the background here, and it will walk you through some of the articles that we write about the feature itself. So in this one, we're looking at what's new in IBC 2012, and we break down what happened in here and how to get to it, and some of the different maybe changes of this that happen in our website. So if you're not familiar with RISA News, that's a great website. It's just www.risanews.com, and you'll see weekly articles that we write and post on our website, and gives you some of the newer stuff that's happening. But even sometimes folks call into technical support on things that happen all the time. We put that here on our RISA News so that we help other folks to understand what's going on there. So we've got a lot of different things happening on the website if you haven't visited. So basically that's the end of our topic today for new features in RISA, and we covered RISAFloor, RISA 3D, RISAFoundation, and RISA Connection.